Hello friends, in this video I am going to show you a demonstration on collection and visualize data in ThingsBoard IoT Platform. Main goal of this demonstration is sending data to the IoT platform, analyze data on the IoT platform, visualize the collected data on dashboard. What you will see in this video. First we will see how it works. And next we will see the demonstration on data collection and analytics. Let's see how it works. So this is my test setup for the demonstration. It consists of Raspberry Pi, a single board computer, and Node MCU. They both connected to the ThingsBoard IoT platform. Let's see the process in this demonstration. The endpoints will send the data to the IoT platform. The IoT platform will analyze the incoming data and we will visualize the important collected data on dashboard. So this is the flowchart for my demonstration. Raspberry Pi will collect data from the sensors. The collected sensor values will be sent to ThingsBoard IoT platform, and in the side of Node MCU it always wait for an event. So in my demonstration I made button press as an event. So whenever that event occurs, it notifies that to the ThingsBoard IoT platform. While in the analyze part also, the IoT platform will analyze the sensor values from the Raspberry Pi. Whenever the sensor value is above from the threshold value, then it triggers alarm. Similarly, another analyze rule is it always wait for an event from the Node MCU. Whenever the event occurs from the Node MCU, it triggers another alarm. So here we are setting two rules for the analyze part. One for Raspberry Pi and next one for the Node MCU. So before getting into this, first we have a look at ThingsBoard IoT Platform. ThingsBoard is an open source IoT platform that enables rapid development, management and scaling of IoT projects. ThingsBoard is scalable, fault tolerant, customizable, robust and efficient. ThingsBoard provides the provision for collect and visualize data from devices, analyze data and trigger alarm with complex event processing. So step 1, ThingsBoard installation. In this step, we are going to install the ThingsBoard IoT platform. To install ThingsBoard IoT platform on your local machine, have to go to this link thingsboard.io. For documentation, just go to this link docs. For getting ThingsBoard, just click on try it now. So ThingsBoard comes with two editions. One is community edition and next one is professional edition. Community edition is free to use, but professional edition you have to pay for that. So I am going with community edition. Various installation options are available in ThingsBoard. You can install it on a Windows machine, Linux machine too, and for Mac users too. And you can install it on even Raspberry Pi, and you can install using Docker. That's using containerization. So Docker is a computer program that performs operating system level virtualization. So I'm using a Linux machine. I'm going with this. When we are seeing the minimum hardware requirements to run ThingsBoard, the minimum system requires at least 1 GB of RAM, and it requires Java Oracle JDK of 8 version. Choose the appropriate OS which you are using and install the JDK 8. By default, ThingsBoard use embedded Hyper SQL database, and it also allows users to optional database installation, that is PostgreSQL and Cassandra. So these are optional steps. If you need this, you can follow this instruction. So I'm going with the default steps. Follow these two steps to download the the bin package of ThingsBoard and install that package. While on installation, if any error occurs, the ThingsBoard logs are stored in where log ThingsBoard. So go to this log file and we can easily find out what's there. Step 2. How to set up the IoT platform. In this part, we are going to set up our ThingsBoard IoT platform. After installing the ThingsBoard, we have to start the ThingsBoard service. For that, go to a terminal and just enter this command: sudo service ThingsBoard start. Switching to your browser, enter the IP of the system and port number will be 8080. This is the ThingsBoard login page, and default username and password will be, the username is thingsboard@thingsboard.org and password is tenant, TENAND. Just log in. So this is the home page of ThingsBoard. These are all available options available on Community Edition. And first we need to add 2 devices, one Raspberry Pi and one for Node MCU, and then we define rules for analyzing the incoming data coming from the devices. Then for visualization, we create dashboards. In device management, the devices are managed in this section, and in rules management, you can define rules for the incoming message for analyzing. And in customer management, you can manage your customer who all can view your dashboard or who all can access your data. And in dashboard management, you can create dashboard widgets. So first I'm going to device management. And for adding a new device, just click this and you can name the device. I'm going with test device 1 and test device. If you want a gateway, you can just click this option. I'm not going with the gateway. So the access token is the identifier. So the ThingsBoard identify the device using the access token. So every device is created will have a different access token. And you can see that the top, so there are attributes, latest telemetry is all there. Attributes, these ThingsBoard provides the ability to assign customer attributes to our devices. Attributes may be device name or device serial number, firmware version, like this. Telemetry means it's a time series key value pair. Using the telemetry API, we can able to send time series data to the internal storage of the things. So the static values will be the attributes. Set any alarm rules means it will be notified here. In this, I created 2 devices. One is for my Raspberry Pi and another for my Node MCU. So we created 2 devices. Next, we need to define rules for analyzing the message. Step 3. Analytics on data. In this step, we are going to make rules to analyze the data. Just click on the rule chains. And similarly, for creating new rule, these are all new rule chains. Just over here, and you can test rule. ThingsBoard allows us to use debug mode. If we enable debug mode, we can able to debug our code whether our logic is correct or not. So these are the components provided by the ThingsBoard: filter, enrichment, transformation, action, external rule chain. So filters, filters basically it filters the message. Suppose we need a temperature from the incoming data, So we can filter the temperature part only from the message. So these are all components available in filter. And in enrichment, these are based to attributes. You can, so even ThingsBoard can assign attributes, or it can extract attributes from the devices. So such components are available in this section. And transformation. So using this script, we can transform the incoming message into some other format. Means we can use these components. And action. So basically the alarm, creating alarm, clearing alarm, RPC, request and reply. RPC is basically a remote procedure call. So suppose one controller is there, it need to get temperature from the device. So it can send an RPC request to the test device. So as a reply, it get the temperature. So these all functions are happening through the RPC. And ThingsBoard allows us to integrate with the external cloud services, AWS. Some plugins also. These are the available plugins in the ThingsBoard. In the earlier ThingsBoard versions, you can see one option will be that plugins. Now in the newest version 2.0.3 from onwards, they added plugins in the rule chain section, and I will show what the rule I'm using for Raspberry Pi and Node MCU. So for Raspberry Pi, so the message will be coming. I'm checking the threshold check. So whenever the temperature is lower or within the limit or it's outbound from the limit. So within the threshold means it clears the alarm, or it doesn't do anything. So whenever it extracts it from the threshold means it will create an alarm. In debug mode, we can check whether our logic is working or not. So you can check when enter your any temperature value. So you can check. Now the boolean is false. So when I change the temperature value to 50, so it becomes true. You can check the logic is working or not. So in my node MCU rule also, instead of checking the temperature, I'm checking for the event occurs. Whenever the event occurs, it will raise the alarm. So using debug mode, you can check for the logic. And so these are the two rule chain. So my root chain will be this one. So I need to link these two rule chain to my root rule chain. So for that, I'm going to my root rule chain. So the root rule chain will be, the input will be coming here, and this filter will switch the message according to the message type. So attributes will be going this way and telemetry will be going this way. So the RPC request from the device and reply from the device are going this way, and other messages that are not included in this switch type are go to this, and it will be recorded on the log. So now I'm only concerned on my post telemetry. So from here I'm adding my rules. So I'm using this rule chain option. So I add my node MCU rule similarly and Raspberry Pi rule. Step 4. How to set up the dashboard. In this step, we are going to set up dashboard on ThingsBoard IoT Platform. To set up the dashboard, go to dashboard, click on new, add new dashboard, enter any dashboard, testing dashboard, add dashboard, and here you can add widgets as much you like wish. Click on add new widgets. So ThingsBoard inbuilt comes with many widgets, so you can add new widgets as much you wish. So from this menu you can access all the widgets. So this is the dashboard which I created for the demonstration. You can customize it in your own way. Widgets are all available. So these are analog gauge, and this is digital, and this will be the chart type. These are all available in the ThingsBoard itself. So this window is for alarm, whenever the alarm triggers. So this alarm for Raspberry Pi. So it's for checking the temperature. And below, so this is the attributes value. So I'm sending 3 attributes, customer attributes. something like device name and firmware and serial number. So these three attributes I'm sending from the node MCU. So I'm displaying it on the dashboard, and this is one digital gauge widget shows my button value. So now I'm not ready with the device. So 0 means we're not getting any data, and this window is the alarm window for my node MCU. So whenever the event occurs, it will display the details of the alarm. So now we set up the device and set up the rules, and now we add our dashboard. So now we move to endpoints and we set up the endpoints, then we check on our dashboard. Step 5, how to set up endpoints. In this step, we are going to set up our endpoints, Raspberry Pi and Node MCU. So next we need to set up our endpoints. So this is the code for the Raspberry Pi. So in Raspberry Pi, I'm using Paho MQTT client library. So it's available in GitHub. And in this code, you have to enter your IP address of the ThingsBoard and access token. You have to place your access token of your device. So we can have it on here. So Raspberry Pi, and copy the access token and paste it over here. So the Raspberry Pi is sending some 4 sensor values. So one is temperature, humidity, third one is air quality and light intensity. So in this scenario, I'm not using any sensors. So these sensor values are sent based on some random numbers. So this function will take care of this. This will send some random numbers for the temperature, humidity, air quality and light intensity. So this is the code for the Node MCU. So in my case, my Node MCU is flashed with MicroPython firmware. If you are hearing MicroPython for the first time, means please visit my previous videos in my channel. Actually, my Node MCU comes with some Lua firmware, so we can custom flash the MicroPython firmware. So in my previous video, I'm showing how to flash the MicroPython firmware and how to use it. So some MQTT are inbuilt with that MicroPython. So in here also, instead of sensors value, I'm sending event. So button press is my event. So here also have to enter the IP of ThingsBoard and my access token. So this is my access token. So for that, you go to Node MCU, this is my device, and copy access token and paste it over here. So my button is working on based on interrupts. So it always wait for the interrupt. Whenever the interrupt occurs, then it will send the message as event. So next I need to dump these 2 codes on Raspberry Pi and Node MCU. So these 2 sample codes are available in the description section. So you can download this code and just change your access token and IP, and you can check on your system too. Step 6, demonstration. In this step, we are going to run our demonstration. So next we need to dump our code to Raspberry Pi and Node MCU. So our devices are ready to run the code. Just copying this code of Raspberry Pi. I'm accessing my Raspberry Pi. So you can see I already pasted the sensor.py is my code. So I need to run my code. So .python sensor.py. So I started my code. So it's printing the sensor value. So similarly, in Node MCU I need to dump the code. So this is the code for Node MCU. Just copying over there. So and I just flashing on to my Node MCU. Yes, connected. It's waiting for the interrupt. So I just check whether my button is working. Pressing the button. Yes, working. So next we can move to ThingsBoard. Yeah, this is my dashboard. So this is my dashboard I created for that. So you can see the temperature, the values are being
changing. So you can see the time log also, and see, you can notice that when the temperature, previous temperature was 42, that's why it triggers the alarm. Now also the temperature is 42, so you can see the notice the time too. It will save the alarm with the timestamp too. And this is the temperature value sent from the Raspberry Pi, and this is the air quality, and this is the light value sensor, and this is the humidity value, and it is all displayed on the chart form. So these all widgets are available in the ThingsBoard itself. So this is the alarm window. This will show the status of the alarm. When the alarm shows, it will shows cleared means the alarm is clear. So whenever it triggers alarm means it will show the active, clear, something like such like that. So this widgets all belongs to Node MCU. So you can notice that in our core in Node MCU we are sending attributes value, device name, firmware, and serial number. So such customer attributes are displayed on a widget. So this is a static values, and this is the digital gauge for showing the value of a button, and this is the alarm window. Now I didn't press, that's why. Now I'm going to press my button. So I'm just pressing the button. So you can notice that it changed the value to 1, and you can see the timestamp. Now I will show you now full screen mode. Yeah, you can see that now the 2016, you can see that now alarm is created. Now its status is active. So again I'm pressing the value to clear the alarm. So pressing the button, alarm is clear. So likewise you can do more stuff on the ThingsBoard. So thanks for watching this video. I hope that you enjoy this video. Subscribe to my channel if you haven't subscribed. Thanks for watching.